The next step is to learn about the ins and outs of MIDI. When connecting several MIDI devices together, you attach the MIDI cables to the MIDI in, MIDI out, and MIDI through jacks. You may or may not find all three on every device, so locate these jacks on your MIDI equipment. Each one has a very specific function, and in many cases, the available jacks determine where a device will be placed when setting up a MIDI system. A MIDI in jack is where a device receives incoming messages from another piece of MIDI gear. In other words, by connecting a cable to this jack, your device can be slave to some other piece of MIDI equipment. On a tone generator, this provides access to its sounds. On a sequencer, this allows you to record the performance from a master controller. Any outgoing messages from a master or controlling device are sent from the MIDI out jack. This is connected to another unit's MIDI in. Let's try an example. Open your workbook to System 1. In this system, Controller A could be any master controller, a MIDI percussion unit, a wind MIDI controller, etc. In this case, it's a keyboard controller that makes no sound of its own. Synthesizer B, also a keyboard, has stereo audio outs labeled left and right. Let's say we want to control the tone generator in Synth B. In other words, we want to play A and hear B. Also in this system is a mixer, power amp, and speakers. Now, using solid lines for MIDI and dotted lines for audio, pause the tape now and take a moment to fill in the appropriate MIDI and audio connections. In this example, Controller A sends data to Synth B, so connect A's MIDI out to B's MIDI in. To hear B's audio, connect its left and right audio outputs to inputs 1 and 2 on the mixer. The output from the mixer goes to the power amp, and the power amp goes to the speakers. Many devices also have a MIDI through jack. Messages that enter at MIDI in pass through the device and are sent unchanged from the MIDI through jack. Notice how this differs from the MIDI out, which sends data that comes from within the device. MIDI through is useful for linking several devices together in a MIDI system. Let's say we have MIDI controller A and 3 MIDI synths, B, C, and D. Each synth has its own keyboard and sound source. Now the basic rules of MIDI say always connect a MIDI out to a MIDI in, or always connect a MIDI through to a MIDI in. If you are playing the master controller and want to get to all of these devices simultaneously, connect its MIDI out to MIDI in. From here, it's MIDI through to MIDI in, through to in, and so on. This is called daisy chaining. In this example, Controller A could simultaneously play B, C, and D. In addition, B, C, and D can also be played independently, without controlling anything else, since their MIDI outputs are not being used. Here you can see that when laying out a system, a device that does not have a MIDI through jack must be connected at the end of a chain. Because MIDI data has no way to pass through it, it must obviously be the last device in a chain. Okay, let's review things for a minute. As you design a MIDI system, keep in mind how you want a specified piece of equipment to function. Will it be a master controller, a slave device, or both? Also, what MIDI jacks does it have? This will help you decide how to lay out your MIDI system. Open your workbook and take a look at System 2. Here, you'll notice 2 synthesizers and a drum machine. Synthesizer A will be our controlling keyboard. It has a MIDI in and a MIDI out jack. Synthesizer B will be a slave sound source. We may occasionally want to play its own keyboard and listen to its sound without controlling any other MIDI device. Notice that it provides in, out, and through jacks. The drum machine may be played by itself, or we may access its internal drum sounds from Master Keyboard A. It has MIDI in and MIDI out jacks. Also, notice the 6-input audio mixer, the power amp, and the speakers. Again, using solid lines for MIDI and dotted lines for audio, pause the tape now and take a moment to sketch out the MIDI and audio connections for this system. To use synthesizer A as the controller and synthesizer B as the slave, connect A's MIDI out to B's MIDI in. To also control the drum machine, connect B's MIDI through to the drum machine's MIDI in. Now let's look at the audio connections. Connect A's single audio out to one of the mixer's inputs. Do the same for synth B as well as the drum machine's stereo audio outs. In this system we can play synthesizer A and just hear it and synth B without the drum sounds. Or we can play A and just hear the drum sounds. Or we can hear all three together. Remember earlier we briefly mentioned that MIDI allows you to send and receive messages on different channels. In this way, you can control specific devices within a more sophisticated MIDI system. MIDI channels work in much the same way as television channels. For example, let's say you want to watch the evening news on Channel 2. There are also several other stations that broadcast their evening news, and your TV antenna picks up all of these stations. So you get up, you walk over, turn the TV on, and select Channel 2. Your TV ignores the programs on all other channels and just shows you the news on Channel 2. In MIDI, there are 16 different channels, and certain types of MIDI data, called channel messages, may be assigned to a specific channel. In addition, many devices allow you to select what channel or channels they will transmit and receive on. If the master and slave devices are set to the same channel, they can talk with each other. If the channel numbers don't match, the slave will ignore the incoming messages. The ability to change, transmit, and receive channels varies from product to product, so check the owner's manual for your specific MIDI equipment to see what it will do. In addition, messages on up to 16 different channels can travel through a single MIDI cable at the same time and still retain their individual channel assignments. In other words, you don't need a separate cable for each channel in a MIDI system. Several channels can travel together at the same time through one MIDI cable and still keep their channel numbers intact at the other end. Now let's apply MIDI channels to System 2. Synth A can transmit on any one of 16 MIDI channels. Synth B and the drum machine can be set to receive on any single MIDI channel. Set B to receive on channel 2 and the drum machine to channel 3. Now, by changing the transmit channel on Synth A, we can selectively determine which MIDI device it will control. Let's hear what this sounds like. By setting A to channel 2, we can just play B. On channel 3, we can now play just the drum machine. Notice, though, that we're hearing the sound from Synth A as well as the drums. There are a couple of different ways around this. Local control, also simply called local, is a MIDI function that lets you play a synth's keyboard, send messages, but not hear its internal sounds. With local control off, you can play Synth A's keyboard without hearing it and still control the drums. With local on, you can hear A's internal sounds and transmit via MIDI. If, in this example, A does not provide local control and we want to play the drums from its keyboard, we could simply turn its volume down, either from its front panel or at the mixer.